Hello everybody, today we are going to solve a question of vector addition where we are going to add two given vectors using components. So we'll start by reading the question. Find the resultant magnitude and direction of the following vectors using their components. So the first vector given is momentum of 100 kilogram meter per second directed vertically up. The second vector given is momentum of 70 kilogram meter per second directed at an angle of 45 degrees below the horizontal. Now, just to put things into perspective, I will start by just sketching the given vectors on the xy plane. We don't need to draw a scale diagram, just sketching it. So I will name the first vector as vector A and the second vector as vector B. So my first vector A is vertically directed vertically up, which means it is a vector along the y-axis. Vector B is at an angle of 45 degrees below the horizontal, which means below the x-axis. So I will draw a line at 45 degrees below the x-axis. So this is my vector B. Now, since we are using components, we will start by finding the components. So let's find the components of each of the given vectors. First of all, for vector A, now we know there are two perpendicular components in the xy plane. The x component of A is pretty easy because this vector is vertically up, which means it will not have any component along the x direction. So AX becomes 0, whereas AY is the entire magnitude of vector A, 100 kilogram meter per second. Now for the second vector B, let's find its components. So Bx, what will Bx be equal to? Bx will be equal to B cos theta, and By will be equal to B sine theta. Now the question is, what is this theta? So we have to be very careful when we are choosing the angle. I always recommend my students to avoid any confusion, always choose the angle starting from the positive x-axis anti-clockwise towards the vector, which is the angle I just labeled. So if I try to work out this angle, it will be equal to 360 degrees minus 45, which is an angle equal to 350 degrees. And this is the angle which I'll straight away use in my calculations. So Bx is 70 cos of 315 and By will be equal to 70 into sine of 315 degrees. Okay, so if I perform the calculations, I end up getting Px equal to 49.5 degree 49.5, I'm sorry, 49.5 kilogram meter per second, because that is the unit of B, and By I end up getting as minus 49.5 kilogram meter per second. Now, please note the sign, negative sign with By, which makes complete sense here. If you just look at the vector B, it's pointing in the downward direction, which means it is pointing towards the negative y-axis, which explains the negative sign. Whereas Bx is positive. Why? Because the vector is still pointing horizontally towards the right, which is the positive x-axis. Now, the third step, we are going to find the x and y components of the resultant vector. The x component of the resultant vector will be nothing but the algebraic sum of the individual x components, and if I work it out, I will get ax equals 0, bx equals 49.5, so the resultant vector will have an x component equal to 49.5 kilogram meter per second. Ry, the y component, will again be just an algebraic sum of the y components of the two given vectors. Ay 100, by minus 49. If I do the math, I end up getting 50.5 kilogram meter per second, and with a positive sign this time, because we can clearly see ay has a larger y component than by. Now, we know it very well that for any given vector, if we know the x component and the y component, let's just say this is the x component and this is the y component. If we know the x and the y component, we can simply find the resultant vector, the original vector, by using Pythagoras theorem. So I'm going to find the resultant of the resultant vector, the magnitude of the resultant vector by simply using Pythagoras theorem. So my magnitude becomes equal to 49.5 square plus 50.5 square, and final answer will be equal to 71. I'm just rounding it off to two significant figures, 71 kilogram meter per second. That becomes the magnitude of my resultant vector. Now, for the direction, we know direction of a vector is given always in terms of its angle. Since this is a right angle triangle, I will be using trigonometric ratio. I can use any of the three trigonometric ratios, sine, cos, or tan. I can just use for now tan theta ratio, and I will be getting theta is tan inverse of Ry over Rx. Ry has been found to be 50.5 and Rx 49.5. And if I do the math here, I end up getting an angle of 45.8 degrees. So this is the direction of my resultant vector. Now, just to put things into perspective, if I would like to draw this resultant vector again on the xy plane, just to sketch it, just to see where it lies, it should be a vector with a magnitude of 71 kilogram meter per second at an angle of 45.8 degrees measured from the positive x-axis. So this will be my resultant r. And if you look at the two given vectors a and b over here in this diagram over here, and if I just try to use the head to tail rule to see the tip to tail rule to see how the resultant would have looked like, I would have ended up with a diagram like this, where the resultant finally would have looked somewhat like what I calculated over here using the components method. So that is about it. I hope it clears your confusions. Have a good day.